Okay, so once again we'll remind this concept. Okay, how operating system is used to run the application software. Now we'll see that. Okay, so first, in the first step, what it will do, application program will be convert into the high level language to the machine level language. That means finally, after transferring the information from high level language to the machine level language, we are getting the information in the form of machine codes, right? So then these machine codes, okay, at t naught, at time interval t naught, initially the machine codes will be transferred to the disk for storing. Okay, so after converting machine codes, initially in the first step at t naught, operating system it loads the application program onto the disk to the memory. Okay, so after that transformation is completed. Okay, that means transfer of operation is completed in the first step. So whenever the data is transfer completed, now the user program issues, okay, now the user program issues the one request signal. Okay, one request signal for execution operation. Okay, so then operating system will raise the one signal. That signal is called as the execution purpose. It will send the one command. Okay, so after getting after the processor will get the command of execution operation, then it will be execute that information. Okay, so processor will perform the execution operation. Then we can say that in time period t1 to t2 we are getting the final result. After completing the execution process, we are getting the final result. Okay, so that result will send it to the next level. So that means user program sends again one more request signal to the processor. What that signal means, it will be sending one command, that is print command. Okay, so after execution is completed, then it will be sending the print command. So then automatically at t3 to t4 the printer command will be issued. Okay, so then the OS will be printing the information. Okay, so first converting, after that storing in the disk, and then it will be raised the one condition. That condition is execution signal will be commanded. The execution command will be sent. So after that it will be executing the information. So then again the OS will be send the one more command to print. Okay, so then once the print command is reached to the processor, then it will be printing that information in time period t4 to t5. So operating system loads the another application program while executing the current application program. So that means first the printing command, that means first operation is already running, and it will be running the another program also while executing the first application program. Nothing but multi-programming will be done, or multitasking will be done in this OS. So this is how the OS performs the task of running the application program. Okay. Now we'll go with the next concept, that is performance. Okay, software is completed. Now we'll go with the performance concept. Okay, so here in generally, how can we measure the system performance? Now we'll see here. Okay, so how can we measure that system performance, and how can we calculate the system performance? Now we'll see here. Okay, so the most important thing is here, measure of a computer is how quickly it can execute the programs. That is the measuring system. Okay, so what is the measure of a computer here? So how quickly it can execute the programs. So to achieve better performance, a designer of the computer system must consider the factors. Okay, so that means the system can execute the programs in fast way. Automatically the performance will be high rate, right? So that means we are getting the performance of the system is high whenever whenever it quickly execute the programs, then that system performance is very high. We can say that like that, right? So here also the most important thing is nothing but we want to find out the measure of the computer. So that is based on how quickly it can execute the programs. So to achieve better performance, for that designer of the computer system must consider some factors. So what are that factors means? These are, okay, to achieve better performance in this computer system, it can be follow some factors. So what are that factors means? Hardware design, instruction set, and another one is compiler design. Okay, so now we'll go with one by one here. So the first one is coming to hardware design. Okay, so this is the hardware design block diagram. Here we'll have the three major contents, that is nothing but main memory and processor, and another one is bus. We know already bus is nothing but it is the connection path to the one devices to another device, and it carries the data as well as address also, right? So main memory is nothing but we can use as for storage purpose, right? And processor is nothing but it is the combination of two units, one is control unit and another one is arithmetic and logic unit, right? So processor will is the combination of control unit and arithmetic logic unit. So CU is nothing but it will be controlling or it will be monitoring the all the activities of system. And what about ALU? ALU is nothing but it will be performing the arithmetic and logical operations like addition, subtraction, multiplication, division, like that. All operations will be performed with the help of ALU unit, right? So here also now the processor will do like that. And now coming to the cache memory. So what is meant by cache memory means, as its cache memory is nothing but we are calling like a small memory. Okay, cache memory is called as it is a very small memory. So why it is used in this system means, so cache memory is used to reduce the time to access data from the main memory. Okay, so what is the use of cache memory means, it is used to reduce the time. Okay, what is the use of cache memory? Reduce the time to access data from main memory. Okay, so that means it will be reducing the time while accessing the data. So for that purpose we can use the cache memory here. Okay, and also it is extremely fast memory, a fast memory type that acts as a buffer between RAM and the CPU. CPU is nothing but here processor. Okay, so now here the processor can access the data. Okay, the processor can access a cache memory quickly than the accessing of the main memory, so automatically accessing of the time is reduced, right? So that means it quickly catching the data means automatically taking of time is reduced, right? So once the time is reduced means automatically we can say that the speed of operation is increased. Okay, so you know, right, what is the speed formula? So speed formula is nothing but that is displacement by time. From the physics we knows this formula, right? So speed is nothing but displacement by time or distance by time. So if the time is reduced, okay, accessing of data of time is reduced, so automatically what we can say that here speed is increased, right? So speed and time is inversely proportional here. If time is increased means speed is decreased, speed is increased means time is reduced, right? So here also accessing of time is we are using cache memory, right? Automatically it will be reducing the time, accessing of time is reduced, so the speed of operation is increased. So we can say performance of the system is improved here. We need what is our aim here? To achieve the better performance, right? So for that we are using these factors. So in the hardware design we are getting with the help of cache memory we are getting the performance is high. Okay, so here we are using the time now. So what is the time rate we are calculating? How much of time it will be how much of time we are using here? Now we will calculate that. Okay, so see here processor clock. So time is nothing but here we are using processor clock. Okay, so all processor circuits are controlled by the timing signal that is known as the clock. Okay, so what is meant by clock here? So whatever the processor circuits we are having, okay, that all processor circuits are controlled by the timing signal, one timing signal that is called as the clock. Okay, so see here what is meant by clock? Processor circuits are controlled by a timing signals. And what is meant by clock cycle? So cycle defines a regular time interval. Okay, so what is meant by clock? Clock is nothing but processor circuits will use as one timing signal that is called as the clock. Clock cycle is nothing but whenever the processor perform the instructions, at the time the processor first divide that instruction into a sequence of basic steps. Okay, so each sequence of a basic step required one clock cycle to execute. Okay, so here we are saying one thing, that is nothing but the processor will perform the instructions first of all. So at the time, processor first divide that instruction into the basic steps. Okay, so in that each sequence of a basic step required one clock cycle. Okay, here we are finding the clock rate ma. So how much of time we are using, that time we will find it here. So how can we find it means, based on clock rate we can find it. Okay, so in that instruction will be divided into basic steps now. So in that each basic step will having one clock cycle for execution purpose. Okay, so here let us see what is meant by clock rate. So clock rate is nothing but r is equals to 1 by p. Okay, here p is nothing but time duration of the clock cycle, or we can say that length of the clock cycle, or we can say that a machine cycle also. Okay, so that means here, so this is the clock cycle. Okay, clock rate is nothing but r is equals to 1 by p. P is nothing but length of the clock cycle or length of the machine cycle we are calling. Okay, so now we have to find out the performance equation in hardware design. Each step in each factor we have to find out the performance value. Okay, so in hardware design, how much of performance we are calculating, here's we'll find it. Okay, so see here, clock rate can be increased. Okay, this clock rate can be increased to achieve for better performance by reducing the time period. Okay, already we know if the time period is reduced, automatically to achieve the better performance, right? So here also, if the clock rate is increased to achieve the better performance by reducing the time period of the clock cycle, so that is called as t is equals to n cross s by r. Here what is r? Clock rate. So here clock rate is decreased, time is increased, right? So if time is increased, clock rate is reduced, right? Here what is t? T is nothing but performance of the parameter. Okay, or we can say that execution time of the program also we can say that. And where n is nothing but number of actual instructions present in the program. Okay, and what is meant by s? Average number of basic steps needed to execute one machine cycle. Or is nothing but already we know, that is clock rate in cycles per second. Okay, so this is the performance equation in hardware design. Okay, so in this hardware design we have one more factors also there in that we can see here. Those are pipelining and superscalar operation. Okay, it's very important for a short answer ma. So in hardware design we have the pipelining and superscalar operation also for achieving the better performance. Okay, so first we'll go with the pipelining operation. So pipelining is nothing but it is improvement in performance. It can be achieved by overlapping the execution of successive instruction using a technique that is called as the pipelining. Okay, so see here, improvement in performance can be achieved by overlapping the execution of successive instruction. Okay, so that is nothing but here pipelining technique is nothing but it is a multiple instructions are overlapped during execution. Okay, so pipelining is a technique where multiple instructions are overlapped during execution. That is the first point. Okay, so in the first instruction execution machine cycle, it loads the another instruction in the same machine cycle. Okay, so one instruction execution is started, in the same way another instruction execution will also started. That means first instruction execution will be started, in its same way the next instruction will be loaded while executing the first instruction. Okay, so here the loading of the next instruction and execution of the current instruction happening in the same duration. That means at a time two operations will be done here. Okay, so that is here, that's the reason here overlapping will be happen. Okay, so here the loading of the next instruction and execution of the current instruction happening the same duration. So then execution times are overlapped. So first execution having some time and the second execution will have some time for execution purpose and for loading purpose, right? So it will having two instructions, that means it will do the two operations at a time. So in the same way, the same duration, so that means execution times are overlapped, so that pipelining is a loading technique of the next instruction while executing the current instruction. So then at a time two operations will be done means automatically time will be reduced. Okay, so in the single clock cycle it will do the multiple operations, automatically the reduce the time of the execution of program. Okay, so that is called as the pipelining technique. So here what is meant by pipelining means it will be improve the performance. So how it will be improve the performance means it will be loading the instruction and also while executing the current instruction happening in the same duration, then execution times will be reduced automatically. The performance will be, that means speed of operation will be increased, the performance will achieve the higher performance. Okay, now coming to the superscalar operation. So superscalar computer consists of more number of the ALUs. Okay, superscalar operation consists of the more number of ALUs, that means arithmetic logic units, which performs the many operations simultaneously. Okay, ALUs will perform the different operations, addition, subtraction, multiplication, like that, right? So which performs many operations simultaneously, so execution time may be reduced, then speed of operation is increased. So then we can say that it will achieve the better performance, but cost is very high as compared to the pipelining computers. Okay, so it is possible to start the execution of several instructions in every clock cycle. Several instructions is nothing but it will consist of the it will consist of the more number of ALUs means, so automatically it will be perform the different task at a time. In single time it will be perform the different operations. Okay, automatically the time will be reduced and performance will be increased. So in superscalar, what is the clock rate? R is equals to 1 by P. So reduce the amount of processing done in one basic step and also helps to reduce the clock period. Okay, so this is the hardware design.